Hello guys, welcome to my channel. Today I am going to explain about Java real-time interview questions. Today I will focus on core Java. Let's get started. Here first question is explain about object-oriented programming principles. There are four main object-oriented programming principles. There are encapsulation, inheritance, polymorphism and abstraction. First one is encapsulation. Encapsulation is nothing but binding the data members and the member functions into a single unit, which is called a class. And also it provides a restriction to direct access to some of the details. Like for example, if you are working for a banking application, then if you want to withdraw the amount, then the amount balance should be greater than 0. Then only you can withdraw. These type of conditions we can add within the class, like by providing getters and setters for private members. For here the examples are, let's take a user example here. We have private string email and private string password. For password we need to add some restrictions, like length should be greater than 6. So we provide getters and setters for this. While setting the password, we will be adding this condition: if password dot length greater than or equal to 6, else we will send a message password is too short. This way we can restrict the access within the class. This is the main advantage of encapsulation. Next one is inheritance. Inheritance is mainly parent and child relationship, where child can access the parent properties and also behaviors, like members and methods from the parent class. Here child class to inherit properties and behaviors from the parent class. This will reduce the code duplication, writing the same methods within the child. This issue will be resolved. So here let's take an example. We have a user class where we have different types of users, like customer and admin. Customer has different types of properties and admin has a different type of properties, but the common property is name and the login functionality. Both should log in and both should have a name. This way we can create parent class as user, and we can create login method and name in the parent class. And within the customer class we can do the things whatever customer is required. Customer can browse the products and admin can manage the products. These two functionalities are depends on each class. Browse product is only available for customer, and manage products will be only available to admin. Let's take an e-commerce app example. Here we create a customer class, c equals to new customer, and then if we use c.login, then login method is not in the customer, but it can access because customer extends the user and the user has the login method. It can directly use the login method. Here customer can log in and he can browse the products. In the same way, here we create admin object and admin can log in. Here admin doesn't have login method. Admin can extend the user and get the login from user. Here admin A equals to new admin, and admin can log in and admin can manage the products. Here manage products and browse products are particular to the same class. Browse product can be only accessible to customer, and manage products is only accessible to admin. User cannot access these methods because these are present in the child class. And this is the concept of inheritance. We can reduce the code duplication by adding the common properties in the parent. And next is polymorphism. Polymorphism is using the same method with multiple forms. For example, here we have polymorphism, which means many forms. In Java, a method or function can behave differently based on the object calling it, and this provides the code flexibility and reusability. Here we have two types of polymorphisms. One is method overloading and one is method overriding. It is also called as compile time polymorphism and runtime polymorphism. Coming to compile time polymorphism, which is method overloading, same method can have different types of parameters or different number of parameters and different return types as well. Here it can have same method name, it should have same method name but different types of parameters. Different types in the sense there can be different number of difference in number of parameters or type of parameters. This happens within the same class and it is identified at the compile time. That's why it is known as compile time polymorphism. Let's take an example of method overloading. Here let's take a calculator example. Here we have add method with the two parameters of integer type a comma b, and one more method with the same name add, same return type and with a different number of parameters. Here is 3 a b c, and here the return type is different. Add of with two arguments same as the first one, but here the type is different. Here it is double a comma b. Based on the given input, it will decide at compile time and it will go to the particular method. If you give same number of parameters with the same name and same type, then compiler will go into ambiguity and throw the error. Here we are creating calculator object. We are calling calculator.add of 5 comma 10. Then this method will be called because it has two arguments with integer type. And if we call calculator.add of 5 10 15, then these three arguments will be called. And if you use 5.5 and 2.5, then this double will be called. This way method overloading is done within the same class. Coming to runtime polymorphism. Runtime polymorphism, a method should have the same name, same number of parameters, but it should be implemented in the child class, not in the same class. This is the difference between method overloading and overriding. It happens in two different classes, parent and child relationship. This object creation will be decided at runtime. So due to this, it is called runtime polymorphism. And it also uses @override annotation to indicate that the method is overridden. Let's take an example of overriding. Let's take a vehicle. Vehicle has a start method, and car and bike extends the vehicle class, and they have their own implementation of start method. Car is starting with key and bike is starting with self start. These two has their own implementation from the vehicle. They have overridden the start method. If start method has arguments, then this start method also should have arguments and the same return type. In main class, vehicle v1 equals to new car. We have used vehicle v1 equals to new car. New car object will be created at runtime and assigns to v1. If you call v1.start, then it is going to call car is getting started with key. And the next one is v2 equals to new bike. New bike is created at bike object is created at runtime and it is going to assign to v2. And if you call v2.start, then it is going to call bike start method instead of calling vehicle. This is the concept of method overriding. It should be in the child class with @override annotation with same method name and same number of parameters. Next question is abstraction. Abstraction is like hiding the implementation details and focusing on whatever the features are required. So here it is implemented using abstract classes and interfaces. and it mainly focuses on what an object should do and not how it does. For example, if you buy a car, then you need to know how to drive. You no need to know about the how engine is created and how the entire car is made. You just need to know the driving. The same way abstraction will work here. Here we have interface payment. Interface will provide the 100% abstraction. Here we have process payments. Here we just have process payments. We don't know whether it is a credit card payment or UPI payment or debit card payment. That implementation is done later, but we have only the process payment option. User can see only process payment. If it is the implementation is not required for the user. This way they can just create a payment and do process payment. They don't need to know what is happening inside the payments. This way abstraction will work for hiding the implementation details. Next, second question. Object-oriented programming principles behind the System.out.println statement. Here we can see how OOPS is incorporated in this statement. Here first one, system. System is an example for encapsulation, where system is a final class from java.lang package, and it hides the internal details and provides controlled access through its static members. It has the static members and it has the controlled access in the system class. That's why it is an example for encapsulation. And the next one is out. Out is the final variable, static final instance from print stream class, and it is declared in the system class. Here print stream is a subclass from the output stream. Output stream is a class where it will print the data in the console, and here it represents the inheritance properties, because output stream is a parent and the print stream is a child class of output stream. And out is static final instance from the print stream class, and it is initialized as this way in system class. Public static final print stream out equals to new print stream. This way it will be initialized in the system class. And if we go to println, println refers to polymorphism with method overloading. Println is a method inside the print stream class, and it is overloaded to support different types of arguments. Like if you give integer to println, it will work. If you give to double to println, it will print. If you give string to the println, it will print. This way it is overridden, and whatever you give in this argument, it will print in the console. These are the concepts behind the System.out.println. Then coming to next question, how does equals and hashcode exactly works? Equals method is basically used for the content comparison. It is present in the object class, and it is used to compare the contents and not their memory references. But the default behavior of equals method is object comparison, memory comparison. If you are not overriding this equals method, then it will work same as double equals to, like comparing the memory references. Here let's take an example. Here class person, it has name and name initialization. It doesn't override equals method. In main class, if we create two person objects, p1 equals to person John and p2 equals to new person John, the name is same, but when we use p1 dot equals of p2, then it will return false, because the default equals compares the memory references, not the content. If we want to get equals true, then we need to override the equals method. Here we can override the equals method this way. Equals method has a boolean return type and accept the object type. And here we can compare this equals to object, then we can directly return true because their memory locations are same and the objects will be same. If object equal to null or class not equals to object class, then we return false because the comparison will not work for two different classes. And if after that we will be converting this given object into person class, and if we want to compare with the name, then we will return name dot equals of person dot name. This will return true if the names are same. Then this way we can override the equals method and we can compare the content instead of comparing memory locations. Next one is hash code. Hash code is generates a hash value which is integer for the object. This is mainly useful in hash based collections like hash map and hash set for locating the objects efficiently. And it has if two objects are equal, returns true, then they must have the same hash code. This is the contract between the hash equals and hash code. If two objects are equal by using the equals method, then they must have the same hash code. However, if different objects can have same hash code, but they are not equal. For example, two different objects can have same hash code. This is called hash collision, but the objects are not same. This scenario also can happen. And here objects dot hash of name comma age. This will create a hash hash code based on the name and age, like by using the object field. And if we want to do custom hash code to avoid the collision in the sense like different objects which are not equal can also have the same hash code. If you want to reduce those scenarios, you can multiply hash code with a prime number. This will help in reducing the collisions. Here you can get name dot hash code and you can multiply result with 31, which is prime number, and if you add age, then you will get one integer result which is better than this default hash code. So this way you can avoid the hash collision. Here the basic rule for equals and hash code is if objects are equal, then their hash code should be equal. If hash codes are equal for two objects, then it might not be equal. This is about exactly working of equals and hash code. Thank you for watching.